Okay, welcome back from your break. This is the fourth video of the 8th lecture in the engineering design course. Up until now, we have walked through the 10 steps underpinning the quality function deployment technique, and I've also walked through the various pieces in the, let's call it the geography of the house of quality to show you what they all do. And now I'm going to give you an example of how to use the house of quality. I'm going to use a very simple house of quality diagram, the one that we've used before. When you do a real design process, your diagram is going to be much larger than mine because you're likely going to have more customer needs and engineering requirements than just the three that I use in my example. But anyway, the point here is to just really show you how to use this tool for your engineering design process. So what we're going to do is assume that we are developing a new product, a mechanical pencil, which is this one here on the top, and the key attribute of our mechanical pencil is the lead diameter, which is going to be 1.3 millimeters in diameter, and that's to increase the mechanical strength of the lead in response to a customer survey that indicated that the thin lead of existing mechanical pencils breaks too often. So we're thickening the lead to increase the mechanical strength of the lead to reduce lead breakage. So that's sort of the overall goal. Now, of course, this pencil already exists. It's not a product that I'm developing, but you have to suspend disbelief here, at least for purposes of this example. Now, there are at least two competitors in this space. So one is an existing mechanical pencil with a lead diameter of 0.77 milliliters and millimeters, and we'll call that competitor 1. And then, of course, the old standby wooden, yellow, and lead core pencil, which has been around for 100 years, that also exists, and we'll call that competitor 2. So our product is the 1.3 millimeter diameter mechanical pencil here on the top. Competitor number 1 is the 0.7 millimeter diameter mechanical pencil in the middle, and competitor number 2 is the wooden lead core pencil here on the bottom. So with that in mind, I will show you the house of quality that I put together. Now, this is completely filled in, but I'm going to go through each individual step in the process of filling it in so that you could see what I did and then see the overall big picture. So the first step, both in our 10-step process and in my description of how the house of quality works, is to look over here at the customer needs field of the house of quality. So I've taken just those generic customer requirements and I've replaced them with real customer requirements. So remember, the main goal is that we want a pencil where the lead won't break, but then as a result of discussing the ideal product with the customers, we learned from them that it's also important that the lead is easy to sharpen, and it's also important that if you make a mistake, it's easy to erase any marks that you've made. So those are our three customer needs, customer requirements that are filled in here in this section of the house of quality diagram. Second, we're going to evaluate the importance of each of those customer needs, and so based on discussion with the customers, again, we find that lead not breaking is the most important customer metric, and so we're going to assign that a value of 5. It's relatively important, more than average in terms of importance, that the pencils are easy to sharpen, so we're going to assign that a value of 3, and then easy to erase was less important than easy to sharpen, and so we're going to give that an importance of 2. So these 5, 3, 2 again are just based on a scale of 1 to 5, 1 being essentially unimportant customer needs and 5 being critical customer needs. And it's a little bit based on kind of qualitative engineering intuition, exactly what numbers to assign, but you've got a scale of 1 to 5 and you want to assign them relative to one another. So that's how those numbers are assigned. Next, we're going to move on to the engineering requirements. So these are the product attributes taken from the customer needs statement, filtered through the formal engineering design process by design engineers, who then arrive at a set of engineering requirements or design requirements. and those design requirements are tabulated here. Before I just had the word, I think engineering requirement 1, engineering requirement 2, and 3. And so I put in the specific requirements of we need a large lead thickness. That's how we're going to address customer need 1 is the lead won't break. We're going to increase the thickness to increase its mechanical strength. In terms of easy to sharpen lead, we're going to address that customer need by what I call one push actuation. So with this mechanical pencil, you just want to push a button essentially once and have new lead come out, which is sharp and ready to use. And then finally, easy to erase marks. We're going to quantify that as a one pass erase. So we just want to be able to go over a mistake one time with the eraser and have the erase be permanent and complete. So I've also highlighted this section, which is my quantitative targets. So for large lead thickness, I've set my quantitative target as 1.3 millimeters. My one push actuation is 1p for one push, and my one pass erase is 1p for one pass. That's just to remind me that those are the quantitative targets that I'm shooting for, or that I've set when I'm trying to achieve the actual outcome, the actual realized product from my engineering design process. Okay, so the next step is to identify interconnections between the customer requirements, and I discussed in the previous video about how to do this, what these different cells mean. So just as a quick recap, I start with the first customer requirement, and to determine how it relates to the second customer requirement, I look how this column and how this column intersect with each other. That's this particular cell. And so a symbol that I put here describes an interconnection between customer need 1 and customer need 2. And so in this case, having the lead not break and having the lead not be easy to sharpen, there is actually a slight positive correlation between those two aspects of the customer needs. So if I improve the ability to sharpen the lead, I'm improving its ability to not break, and vice versa. So I go here to my table, which reminds me what the symbols mean, and a slight positive correlation is just an open circle. So I put that open circle in this spot here to indicate that correlation. Now, in thinking about how lead won't break and compared to easiness of erasure, there doesn't seem to be any connection there, so I don't have any symbol in this cell, and easy to sharpen lead seems to have nothing to do with easy erasure, so I don't have any symbol in this cell either. So there's only one interconnection there that I'm indicating, and that's a weak but positive correlation between the wet lead not breaking and the easiness of the pencil to sharpen. Okay, so I've exceeded my 7 minutes by a little bit here, so I'm going to stop, give you guys another break, and then we'll come back and finish up the House of Quality diagram here in a moment. So see you soon.